plus 1, would it be negative 1? Or would it still be 1?
Yes, it would be negative 1.
Okay.
Yes. So this always switches to the opposite because my original equation says this, Brady. It says y equals a absolute value of x minus h plus k. So whatever this sign is here is opposite of what you actually plugged in. Okay? Because if I plug in a positive 1, okay, my vertex was a positive 1, that's how I get a negative. But if I plugged in a negative, this would say plus then, because it would be a double negative scenario. Okay? So my vertex is 1, 3. So I graph 1, 3. 1, 3. Okay? So I go and plot the point 1, 3. 1, 1, 2, 3. There's my vertex. Okay? Now, from there, I'm going to plug in a point. But what do I know about this graph already off of this here? It goes down and what?
It's gonna be y. No, small.
Small. It's going to stretch because that's a whole number that's larger than 1 there. It's going to stretch. Okay? So I'm going to pick a number and plug it in. The only number I cannot plug in is 1 because I do not want 0 inside my absolute value.
2.
Okay. 2. 2 is easy because it's the number right next to 1. Okay, so I'm going to plug 2 in. So if I plug a 2 into this equation, I get y equals negative 2, absolute value of 2 minus 1 plus 3. What is 2 minus 1? 1. What is the absolute value of 1? 1 times negative 2. Negative 2 plus 3. So my point is 1, 1.
Where's
I'm
2,
sorry, 2.
1?
Isabel, you're right. I lied.
Good job, is
2,
it?
1, right here, okay? I plot that. Look, axis of symmetry. This point reflects over. It is 1 space away, so I go 1 space away. Does this face down? Is it wider? Yes, because my parent function would be here at 0, 0, 1, 1, 1, 1.
I'm confused.
That's your parent function.
Mine looks different.
Tyler, what do you mean yours looks
So
different?
I did it wrong right here, so I screwed it up. So then it's 2, 1, so when I was 2, 1. And then this is the vertex.
Yeah. That's fine. It's fine. It's just my graph is counting, like I have mine divided into different chunks than your graph. It's fine. Okay, so that's how you compare it with the graph of y equals x. Okay, does that make sense? A little bit more sense. What?
So when you try to find the parent function of like y of x, so that's just like
The
one
parent
space over
No.
from
The parent function always has a vertex of 0, 0. My parent function is always this equation right here. What's my vertex? 0, 0, right? If I plug a 1 in there, I get a 1 out. That's how I graph this. Here's my axis of symmetry. Plug a 1 in, get a 1 out. I graph it,
Where's the one
put it over there. What?
Where's the 1, 3? Where's the vertex at? I can't.
It's the line with the dotted.
This vertex?
Nah, for the original, like the 1,
The
3.
original vertex is
Yeah.
always at 0, 0. Is there anything being added in here or subtracted?
No, I'm talking about the one, like the 1, is that, never mind.
This is the vertex of the green one, of this right
Okay.
here, 1, 3.
Okay, then where's the one that where's the 2, 1 that we just graphed?
We graphed the point 2, 1, 2, 1, reflected it over, because that's not the vertex.
Oh, yeah, okay, never mind.
Okay. There you go. Does that make a little bit more sense? So that's how you are comparing it with it.
I see.
Now, here's an
Okay.
equation that involves a word problem, because we actually use this stuff in science and different things. I know that's probably shocking to you, but we do. Okay, holograms. In holography, is that how you say it? Holography? Light from a laser beam is split into 2 beams. Okay, so beam 1, beam 2. Okay. Light from the object beam reflects off an object and is recombined with the reference beam to form images on film that can be used to create 3-dimensional images. Write an equation for the path of the reference beam. Okay? For the path of the reference beam. So here's what you're doing. It's hard to see these points, but I'm gonna tell you what they are. That top point where the vertex is up here says 5, 8. Okay? This point down here says 0, 0. They want us to create an equation for that beam. How can I create an equation off of that information?
You could plug in the 5 and
I could what?
8. Plug in the 5 and the 8.
Plug in the 5 and the 8 for what? For the H and K. Okay, good. So I'm going to say y equals a x minus 5, right?
8 plus 8.
Plus 8. Okay, plug that in. Now what do I do? How do I get the rest of that equation? Okay, what, Tyler?
Don't you plug something in for X?
I do have to plug something in for x and for y. What other point do I have? 0, 0. So I plug in 0 for y equals a 0 minus 5 plus 8. What is 0 minus 5? 5. So 0 equals a absolute value of negative 5 plus 8. What is the absolute value of negative 5? 5. So I get 0 equals 5a plus 8. Now what do I do? Subtract 8. So negative 8 equals 5a, then what? Divide by 5, right? And you get a equals negative 8/5. Now I can plug all the information I have into my equation. Y equals negative 8/5 x plus 5? No, minus 5, right? Minus 5 plus 8. There's the equation of that graph. Does that make sense? Does the graph face down?
No,
Yes, it does. Look, this
Yeah,
graph
yeah,
faces down. This vertex is here and the graph's going whoop, whoop. Okay? You did it. No, almost done.
Please don't erase yet.
Give me 1 second.
We're gonna run out of
This
time.
rocket science.
It's not rocket science, I promise.
It's light refractivity. Yes.
What? What's your question? Yes. Okay, next one. Okay, transformations of any graph. So we can kind of apply this information to any type of graph that we do. You're going to apply this information to any type of graph that you do. The graph of y equals a times the function of x minus h plus k can be attained from the graph of any function y equals f of x, okay, by performing these steps. Step 1, stretch or shrink the graph according to what the a is, the in front, okay, stretches or shrinks it. Step 2, reflect the resulting graph from step 1 in the x-axis if a is less than 0. No. Yes. And then number 3, translate the resulting graph from step 2 horizontally h units and vertically k units. So we're going to do this with 2 other graphs. So here's a graph. It's 0, 0, 2, 3, 5, 3. They give us 3 points on there. Okay? They say the graph of the function y equals f of x is shown. Boom. Sketch the graph of the given function y equals 2 times the function of f of x. What do I know about that graph? What's going to happen to that graph? If it has a 2 in front of it, if it's getting multiplied by 2 in the front, what's going to happen with it? It's going to get taller. It's going to stretch by 2 units. So here's what you do when it's a function like that. I literally take these points and I'm going to multiply them by 2. But I'm only going to multiply the y value. Here's why. Because I'm stretching the graph, that means it has to grow vertically. Yes? Okay? So vertically is my y-axis. So if I take these and say I plugged these points in, like 0, 0 to this equation, I would get 0 equals 2 times 0. What do you get? 0. So that point stays the same. If I plug in 2 and 3 to this equation, okay, I would end up getting this. If if I wanna figure out what y is, I would say y equals the 2 times my x, which is,
Three.
no, times my function of x. My function of x would be 3. Here's y. This equation says y equals the function of x. So when I plug x in, I get a y out. When I plug this x in, I get 3 out. That's the coordinate pair there. Okay? So when I go to plug in my information, I have to plug in what the solution was to the original equation. So when I plugged a 2 in, I got a 3 out. So 2 times 3 is 6. So my new point is 2, 6. 3, 4, 5, 6. It'd be like up here. Okay? If I plug the same thing in over here with 5, 3, when I plugged 5 in, I got a 3 out. So my equation again is going to say y equals 2 times 3. Okay? So 3 times 2 is 6. So I go to 5, 6. And here's my graph. Okay? I've now stretched that graph by 2 units. Now down here, this one says negative f of x plus 2 plus 1. What does the plus 2 plus 1 tell me? Your vertex. So my vertex is no longer what? It's going to be what instead? Negative 2 plus 1. Or negative 2, 1. So my vertex is negative 2, 1. Good. Negative 2, 1. That's my vertex. Okay? Now, what else do I know about this graph with this negative out here? It's going to go down. It's going down. Okay? So if it's going down and it's opening up downward, then I have to think about what those points would look like. Here's what you're going to do. There's 2 ways you can do this. One's visually and one's mathematically. Visually, I could pretend that I am flipping this graph over this axis. If this is 2, 3, what would the point be down there? It would be positive 2, negative 3. Okay, positive 2, negative 3. And this point 5, 3 would then be 5, negative 3, right? Okay? 2, negative 3, 5, negative 3. And what happened is all of these things were shifted negative 2, 1 units. Okay? So you did this in geometry last year when you shifted and reflected things with translations and transformations. Same thing is happening here. Okay? So my graph has to shift, these points here have to shift negative 2, 1. So if I add negative 2 and 1 to 2, negative 3, what do you get? If I add negative 2 to the x of 2, what do you get? 0. If I add 1 to the negative 3 of y, what do I get? So my point is 0, negative 2. What happens when I add negative 2 to 5? 3. What happens when I add 1 to negative 3? So my point becomes 3, negative 2. And here is that graph. So you have to apply stuff you learned from geometry last year into this. And the rules that we learned about the vertex changing into this. Okay? So, that's what your homework's over. We will look at it again tomorrow, I promise. Okay. Stop that time. Oh, yes. Yeah, thanks. Bye, friends. Okay, let me give you homework.